On the night of September 7th, 2025, the world witnessed a celestial performance unlike any in living memory. As Earth's shadow slowly consumed the moon, millions turned their eyes skyward, expecting only a familiar eclipse. Yet what came next shattered every expectation. The heavens erupted in a surreal blaze of neon green, stretching from horizon to horizon. For a few trembling moments, the night itself seemed to pulse with alien light. Amateur astronomers scrambled to aim their telescopes. Photographers fumbled with tripods. Children pointed with wide eyes. The moon was cloaked in shadow, but the sky, our sky, burned with a color that should not have been there. Through shaky lenses and borrowed cameras, a streak appeared, an icy blue traveler that, impossibly, shifted into a glowing emerald hue. It didn't fade with the eclipse. It lingered. It persisted. The color clung to the night long after the moon slid free of Earth's shadow. Something had arrived. That night, whispers spread across online forums. Words like unnatural, not local, impossible. Amateur observers in Buenos Aires, Nairobi, Lisbon uploaded raw images within hours. A pale streak of light arced across the starfield, each frame deepening into saturated green. In Sao Paulo, a student with nothing more than a borrowed DSLR captured the exact moment of the color shift, timestamps locked at 0318 UTC, aligning with a sudden spike of chatter across the globe. In Cape Town, a retired engineer used a 6-inch Newtonian telescope to track the object. Within minutes, he measured an angular velocity so rapid that even short exposures showed displacement against the stars. The numbers told a chilling truth. This was no ordinary comet. Its apparent motion was nearly a quarter of a degree per hour, blistering speed far beyond anything expected from a local wanderer of our solar system. Across Europe, observers compared notes. Some argued over faulty filters, others debated calibration errors, but the raw frames told the same story. The emerald glow was real. It did not wash out under city lights. It did not vanish when the moon returned. The sky itself seemed branded by its presence. By dawn, the evidence was undeniable. Teachers in rural Turkey posted time-lapses showing the eerie transition, frame by frame. High school clubs in Morocco charted its shifting coordinates. Metadata flooded in. Exposure times, filter bands, calibration notes. What began as isolated glimpses had now become a global confirmation. And with that, a new phrase was born: the night the sky went green. From backyard rigs to the world's largest telescopes, every instrument turned toward this mysterious visitor. It would soon earn its name, 3I Atlas, the third confirmed interstellar object ever discovered. Unlike anything we had seen before, it was tearing through the solar system at nearly 98 kilometers per second, carrying with it riddles no earthly science was ready to answer. Why would a comet from another star system paint our skies emerald? Why would its color refuse to fade? These were not idle questions. For astronomers, for dreamers, for anyone who looked up that night, this was the beginning of a mystery that could rewrite what we thought we knew about the cosmos. Welcome to Lumora, where science meets mystery. Tonight, we unravel the story of 3I Atlas, the interstellar visitor that turned our sky green and left us asking whether we were truly alone. In the hours after the emerald blaze lit the heavens, the world's digital pulse quickened. Astronomy forums, usually quiet corners for patient skywatchers, erupted into chaos. Threads ballooned with jagged screenshots, raw exposures, and frantic notes. Coordinates scrawled on paper were typed in haste. Spectral sketches were uploaded with trembling hands. What had begun as a handful of strange images was quickly becoming a flood of undeniable proof. From a quiet village in Turkey, a teacher posted a time-lapse that captured the transformation frame by frame. A faint streak shifting into a saturated green ribbon, glowing stubbornly against the night. In Morocco, a group of high school students carefully charted the object's shifting position against background stars, confirming a velocity that no ordinary comet could achieve. Across South America, images poured in from Santiago and Buenos Aires. Though the exposures varied in quality, every frame told the same story: a streak of light moving with blistering speed, wrapped in an otherworldly hue. In Nairobi, a grainy capture still revealed what mattered most. This was something moving too fast, too bright, and too strange to be dismissed. Normally, amateur networks disagree. Calibration errors, faulty filters, conflicting observations. Consensus takes weeks, even months. But on this night, within hours, dozens of independent reports aligned. The conclusion was unavoidable. This was no ordinary visitor. By dawn, the phrase, "the night the sky went green," had leapt from niche forums into the bloodstream of global social media. A single hashtag surged across platforms, first in local languages, then in English, until it reached international news feeds. Morning broadcasts that had planned routine coverage of the eclipse pivoted instantly to the mysterious green light. What began as curiosity now turned into scientific urgency. The world's telescopes, from backyard rigs to 10-meter giants, swiveled toward the same point in the sky. Data pipelines that usually trickled with slow, methodical uploads now overflowed with images, spectra, and position logs. Control rooms across Europe, the Americas, and Asia glowed through the night as tired eyes scanned fresh frames, searching for meaning in the emerald intruder. At the Atlas Control Center, the analysts faced an unsettling problem. Their software, designed to fit new objects into familiar orbits, kept failing. Every attempt to force the data into a closed ellipse collapsed into residuals that refused to settle. The calculations pointed to something extraordinary, an eccentricity greater than 1. It was a number that spelled a single word, interstellar. The team hesitated. Raising an interstellar flag was no trivial matter. False alarms could waste the world's attention, drown the confirmation pipeline, and embarrass entire institutions. But as data continued to pour in, metadata, timestamps, sky charts, the evidence only grew stronger. This was not a comet bound to the sun. This was a trespasser from beyond. For the public, it was awe and wonder. For the scientists, it was a ticking clock. Every hour mattered. Every delay risked losing a once-in-a-lifetime chance to study a visitor from another star. By July 1st, 2025, the flood of amateur observations had reached the desks of professionals who could no longer remain silent. Inside the Atlas control room, monitors glowed with lines of stubborn data. Standard protocol was clear. Wait for confirmation, gather more observations, avoid false alarms. But the object's numbers refused to cooperate. The orbit solver stalled again and again. Each attempt to bind the trajectory to the sun spat out the same result, eccentricity greater than 1. Hyperbolic, not an error, not a fluke, a mathematical wall that could not be breached. A log entry at 0314 UTC captured the unease. If this is real, it's interstellar. If not, we are wasting the world's time. The memory of Oumuamua's frantic discovery still haunted the team. No one wanted another delayed recognition. Pressure mounted. How many hours until follow-up observations became impossible? How much time before the object slipped beyond reach? At 0512 UTC, the decision was made. The Minor Planet Center received the urgent alert. Orbit fitting failed. Eccentricity above 1. Outbound velocity unbound. The flag was raised. For only the third time in history, a visitor from another star system had entered our solar system. Within hours, the object was given its formal designation, 3I Atlas. It joined a list that contained just 2 names before it, Oumuamua and Borisov. But unlike its predecessors, 3I Atlas carried with it a speed that defied imagination. At discovery, it was already racing at 61 kilometers per second. Projections showed it would reach nearly 98 kilometers per second at perihelion, fast enough to cross the distance from Earth to the Moon in barely over an hour. No probe, no rocket, no interceptor humanity had ever designed could hope to match that velocity. The truth settled in with a heavy weight. This was a one-time pass, a cosmic drive-by, a messenger that would tear through our system and vanish forever, leaving only the traces we could capture in the narrowest of windows. Orbit dynamics specialists, some who had spent entire careers modeling the hypothetical arrival of interstellar objects, now watched the data in real time. The hyperbolic path was unmistakable. There would be no return, no second chance. 3I Atlas was here, and then it would be gone. The reclassification was swift. What began as C-2025 N1 Atlas, an ordinary comet designation, was transformed into 3I/Atlas, flagged as interstellar and locked forever into the annals of astronomy. For scientists, it was a triumph tinged with despair. Triumph, because humanity had confirmed its third interstellar visitor. Despair, because the impossibility of interception meant we would never know it fully. By October 3, 2025, it was predicted to sweep within 29 million kilometers of Mars, close enough to tempt, but far too fast for any mission to chase. The countdown had begun. Every available telescope, every spectrograph, every instrument that could be turned skyward was pressed into service. Humanity now faced a sobering truth. The universe had delivered us a gift, but one wrapped in a clock that ticked mercilessly toward zero. As the world's telescopes locked onto 3i Atlas, the first spectral data began to stream in. What they revealed was nothing short of astonishing. For centuries, astronomers had known why comets glow green. The culprit was always the same: diatomic carbon, C2, a molecule whose swan bands flare brightly near 516 and 563 nanometers. Whenever a comet approached the sun, sublimating ice released C2 into its coma, and Earth's instruments recorded the familiar green signature. Predictable, reliable, a rule of cometary science. But 3i Atlas shattered the rulebook. Instead of sharp C2 bands, the green region of its spectrum was dominated by a broad, featureless plateau. Line by line, the expected fingerprints were absent. This was not the chemistry of any comet known to humankind. Even more shocking was the balance of volatiles. Infrared scans revealed that carbon dioxide towered over water by a ratio of 8-to-1. In every other comet studied from the inner solar system, water had always been the primary driver of activity, with CO2 as a secondary player. But here, the roles were reversed. The chemistry was upside down. Other molecules appeared in odd quantities. Cyanogen, sometimes responsible for blue-green hues, was present but modest, nowhere near enough to explain the intensity of the glow. Carbonyl sulfide barely registered. No combination of known volatiles could account for the emerald blaze that painted Earth's skies. And then came the metals. Spectrographs lit up with nickel lines, more than 20 of them, some sharp even in the ultraviolet. Iron, usually nickel's constant companion, was nearly absent. In some frames, nickel outshone iron by a factor of 50. For comet chemists, it was like encountering a fingerprint from another world. Laboratories scrambled to make sense of it. The leading suspect was nickel carbonyls, volatile compounds that could sublimate at temperatures as cold as 25 degrees Celsius. On Earth, they are unstable, fleeting. But in the deep freeze of interstellar space, they might survive for billions of years, lying dormant until a passing star breathed life into them. Iron, by contrast, usually locks into stubborn silicate grains, invisible to spectrographs. The imbalance was not just unusual, it was alien. Dust behavior added another twist. Polarimetric measurements showed deep negative polarization, a scattering pattern more typical of distant trans-Neptunian objects than of inner solar system comets. Combined with early Hubble images, the data pointed to a compact nucleus just a few kilometers wide, wrapped in a CO2-rich coma. To planetary scientists, the message was clear. 3i Atlas had likely been born far beyond the frost line of any ordinary star system. Its chemistry was not just exotic, it was a direct clue to how worlds form in the coldest reaches of the galaxy. Yet the greatest puzzle remained unsolved. The green glow was real, unmistakable, and by every measurement unexplained. Without C2, without sufficient cyanogen, without any known mechanism to sustain such brilliance, the phenomenon defied every model. It was as if the cosmos itself had painted the sky with a color humans were not yet ready to understand. With Earth-based telescopes soon blinded by the sun, attention turned to a single hope: Mars. By late September 2025, the Mars Reconnaissance Orbiter and MAVEN were quietly repurposed for an emergency campaign. It was a gamble, one that required rewriting targeting software, reprogramming instruments, and negotiating fiercely with international teams. The decision came under pressure. Planetary climatology projects were forced aside, congressional committees demanded priority, and engineers raced against the clock. On October 3, 2025, the moment arrived. At nearly 98 kilometers per second, 3i Atlas swept within 29 million kilometers of Mars. The window lasted mere hours. MAVEN and MRO captured ultraviolet flashes, infrared signatures, and precious readings of metal vapor and coma structure. In just 3 hours, MAVEN returned more data on an interstellar visitor than most missions gather in an entire season. For that brief instant, Mars became humanity's outpost on the frontier of interstellar exploration. It was not enough to solve every riddle, but it was enough to prove that when the stakes are high, science can move faster than politics. Yet even as the data poured in, another truth emerged. We had missed this visitor before. Archival frames from October 2023 and June 2024 showed faint streaks, traces of 3AS Atlas hiding in plain sight. Detection pipelines, tuned to discard hyperbolic or color-odd candidates to avoid false alarms, had quietly thrown away the signals that mattered most. Twice, the object had passed across our cameras. Twice, the software told us to look away. The post-mortem was swift and unsparing. Machine learning codes were rewritten to flag outlier trajectories and unnatural color bursts, even at the cost of false positives. The new mandate was clear: no more missed interstellar visitors. But software alone would not be enough. Mission architects pushed for something bolder: rapid response interceptors, solar sailcraft, modular swarms of small satellites, all designed to launch within weeks and chase any inbound stranger before it slipped away. Blueprints that once sat on whiteboards now moved onto funding decks. A new doctrine emerged. When the next interstellar messenger arrives, we will be ready to meet it, not just watch it vanish. By the end of 2025, 3I Atlas was gone. Its hyperbolic path carried it outward, beyond the reach of our instruments, into the silence between the stars. What it left behind was not just unanswered questions, but a permanent scar on our understanding of the cosmos. Its green blaze had no clear chemical cause. Its nickel-rich spectrum had no earthly parallel. Its velocity mocked our technology, and yet, for all that it defied us, it also gifted us something invaluable: urgency. For decades, humanity waited for a signal in the static, a whisper from the stars. Instead, the message arrived as a body of ice and gas, streaking through our system, daring us to recognize it. Whether natural anomaly or echo of design, it forced us to ask bigger questions and prepare for bigger answers. And though 3I/Atlas has vanished into the dark, its legacy endures, a reminder that the universe is alive with messengers, and the greatest danger is not what they bring, but what we fail to see. You've been watching Lumora, where science meets mystery. If this story moved you, consider subscribing so you never miss the next journey into the unknown. The cosmos is vast, and together we'll keep searching.